So now that we've looked at adding and subtracting polynomials using graphical representation or algebra tiles, it's important for us to think about collecting like terms algebraically because let's be honest, drawing out those algebra tiles, while they are great and they are helpful and they are a wonderful tool, they're often not the most efficient use to solve for algebraic expressions. So we're going to start today by looking at collecting like terms and how we determine like terms just by looking at it algebraically. So the definition that you need to know is that like terms have the exact same variables with the exact same exponents. I know it's exact same multiple times, but just get rid of this one there. So like terms have the exact same variables with the exact same exponents. So that's really important. So when we looked at like terms graphically, they had to have the same shape. When we're looking at like terms algebraically, they have to have the same letter and they have to have the same exponent. It can't be one or the other, right? It needs to be exactly the same. So when we're looking, first of all, let's review some terminology. What is a constant term versus a coefficient? Because we're going to see those words throughout this unit and throughout your mathematical career as a student as well. So the constant is just the number. So the constant is a single number. There's no letter attached to it. So in this one, our constant is 2. In the next expression, our constant is -2. So we always want to keep the sign that goes with that number. So the sign in front tells us whether the number is positive or negative. So the coefficient is the number directly in front of a letter or sometimes a group of letters like 7xy. So the coefficient in this term is 7 and the coefficient if this term is -15. Again, we keep the operation or we keep the sign that's directly in front of the number. So in the first one it's positive, in the second one it's negative. And we also looked at classifying polynomials. So monomial has one term, binomial has two terms, and a trinomial has three terms. So when we're looking at classifying these polynomials, our first one has 1, 2 terms, so it's a binomial. So the terms have to be separated by an addition or a subtraction sign. This one only has one term. There are no addition or subtraction signs separating these terms. So this is a monomial. The next one has 1, 2, 3 terms. So this is a trinomial. And the last one has 1, 2, 3 terms. So it's also a trinomial. So it doesn't matter if these terms are a combination of coefficients and variables or just constants or just variables. If they are separated by a subtraction or an addition sign, then they are going to be a trinomial or a binomial or whatever. So now we need to think about what are like terms. So we looked at those graphically. So like terms had the same shape. Like terms algebraically have to have the same letter and they have to have the same exponent. So if we're looking at this first set, 5x and 2x, those are both x's. They have no exponent, so they are like terms. 5a and 3b are different letters, so automatically those are not like terms. -4x and 3x have the same letter, so those are like terms. 3x squared and 2x squared, they not only have the same letter, but they also have the same exponent. They're both a squared, so those are like terms. 5 and -8 are both constants. They have no letters, so those are like terms. -5c and -3c both have a c. They are like terms. -x and 6x, like terms. They both have an x. 2x squared and 4x, well, they both have an x. One is squared and the other is not, so those are not like terms. 4xy and 2xy, they both have an xy. Those are like terms. 3x squared y and 5xy squared, they both have an xy, but the first term has an x squared and the second term has an x, and vice versa when we look at the y's. So they are not like terms because the letters do not have the same exponent. I have negative 6xy and 9yx. These are like terms, even though the letters are in opposite order. It's still the same. I can still write this as 9xy, and that's still going to give me the same term. So as long as they have the same letters, they don't necessarily have to be in the same order. And lastly, 5x squared y minus 7xy. These are not like terms because the first one has an x squared and the second one has an x, so these are they're not like terms. So we can only add or subtract terms if they are like terms. So when we looked at this graphically, we could only simplify shapes that were the same. So we could only add or subtract our large squares together, our rectangles together, and our small squares together. The same applies algebraically. So let's go ahead and simplify these expressions. So when we're simplifying expressions, we need to determine if they're like terms, and then can we combine those like terms. So I have 5x minus 3x. These are like terms, they both have an x, and 5 take away 3 is 2, so I have 2x. B, 4x squared minus x squared. These are like terms, they both have the x and a squared. If there is no number in front of your letter, it's an imaginary number 1. So 4 take away 1 is 3x squared. Part C, I have 6x and 2x. 6x plus 2x, those are like terms. 6 plus 2 is 8, so I have 8x. Part D, negative 4x plus 2x. They are like terms. Negative 4 plus 2 gives me negative 2, so I have negative 2x. So it's important that you remember to put those letters if your expression has a letter. Part E, these are like terms. They both have an m. Negative 5m plus 2m. Negative 5 plus 2 gives me negative 3m. And lastly, F, negative 7x plus 7x. These are like terms. They both have x's. Negative 7 plus 7 is 0, so I have 0x or just 0. So anytime you have 0x or 0y, it's just going to be 0. So this would be one where if I was looking at this algebraically or graphically, I would have the same amount of positive shapes as I would negative shapes, and they would cancel each other out. So that's why it's 0. So now we're going to look at some expressions that are a little bit more complicated. So we have more than one type of term in this expression. So here I have a 5x plus 2x plus 4 minus 7. So my 5x and 2x's are like terms. So I can combine these two, and my 4 and my negative 7 are like terms. So I can combine those two. So I can only simplify the terms that are the same. Some people choose to highlight the expressions in different colors to show that those are like terms. They use different versions of underlining them with a squiggle line versus a straight line. It doesn't matter how you group these objects, which way works best for you, as long as you come up with a strategy that works. So 5x plus 2x, 5 plus 2 is 7, so I have 7x. 4 take away 7 is minus 3. So this expression simplifies to 7x minus 3. The next one, I have 3x squared. If I wanted to highlight my x squareds, I could. If I wanted to underline my x's, I can do that to distinguish the two different types of terms that I have. So I'm going to combine my x squareds. So 3 take away 5 is negative 2. So I have negative 2x squared. Negative 4 take away 2 is negative 6. So I have negative 6x. So this expression simplifies to negative 2x squared minus 6x. So this was a question where, these were questions where our like terms were already grouped beside each other. So it made simplifying those a little bit easier. So when you are working with more than one group of like terms, like we had up above, it's helpful for us to rewrite the expression by grouping the like terms beside each other first. So this is known as combining like terms. So let's take a look at some examples that involves that. So this is again where that idea of either highlighting them in different colors or underlining them would be very helpful for you. So break out those highlighters or those colored pencils if you want to. I'm going to start by highlighting all of my terms that have an X. And I want to keep the operation that occurs in front of that term as well. So I have 6x and negative 3x. So those are like terms. The next set of like terms I have is a positive 2 and a positive 5. So my constants are also like terms. So now I'm going to rewrite this so that my like terms are directly beside each other. So I'm going to start with my 6x, take away 3x, then my plus 2, plus 5. So now that I've grouped them beside each other, then it sometimes is easier to simplify it. So 6 take away 3 is 3x, and 2 plus 5 is 7. So this expression simplifies to 3x plus 7. Let's go ahead and look at the next one. This time I'm going to start with my first term. It's a 4x squared. So I'm going to go and see if I have any more x squares. I have another one right here. I'm going to keep that negative sign in front of that as well. Now I'm going to look at some other like terms. I have a 2x and I also have a 9x. So those are like terms as well. So now I'm going to rewrite this by grouping my like terms together or combining my like terms. So I have 4x squared minus x squared, remember to keep the sign that's in front of it, plus 2x plus 9x. So now when I simplify it, remember if there's no number in front, it's an imaginary number 1. So if it's helpful for you to draw that in, go ahead and do that. So 4 take away 1 is 3. So I have 3x squared. And 2 plus 9 is 11. So I have 11x. I can't combine this any further because the x squared and the x's aren't like terms. The next example, I'm going to bring out my highlighter. I'm going to start with my first term. I have a 5a. I'm going to go across and see if I have any more a's. Right here at the end, I have a plus 3a. So those are like terms. I'm going to go with my underlining. I'm going to go with my next term. I have a negative 3b. I'm going to go across to see if I have any more b's. I have a negative 4b there. And if I wanted to, I could circle or I could leave these not underlined. You pick a strategy that works best for you. I'm going to not underline or highlight my C's to show that those are like terms as well. So now I'm going to group my like terms or combine my like terms. I'm going to start with my 5A plus my 3A. Next is a negative 3B. I keep the operation that's in front of it. Minus 4B. Now my C's plus 2C. And then minus 7C. So last step is to simplify or combine my like terms. 5 plus 3 is 8A. Negative 3B minus 4B. Negative 3 take away 4 is negative 7B. And 2 take away 7 is negative 5C. You'll notice that this is written as A, B, and C. Mathematicians like to, when we are expressing our equations or our polynomials, to write our letters in alphabetical order. Also, if we look at B, we've used our greater exponent first, so x squared is larger than our x, so we like to write it in that order as well. That's just good mathematical format. If you're starting out and you're not writing them in order from largest to smallest or in alphabetical order, that's okay, but the more you do it, you should start to get into this habit. All right. The last example we're going to look at, we're going to take our highlighting tool again. We're going to start with 6x squared. Going across, my next x squared is a positive 2x squared. Let's try that again so we get it all in there. Perfect. All right, the next is our x's. So I have a negative x. Going along, I have a negative 4x. Those are all my x's, and then my constants, so my plus 5 and my negative 7, I'm not going to underline or highlight. So I'm going to group my like terms. So 6x squared plus 2x squared. Next is our negative x minus 4x. And lastly, our constants, plus 5, take away 7. Now I'm going to combine those like terms. 6 plus 2 gives me 8x squared. Negative 1, remember there's a 1. Negative 1 take away 4 is negative 5x. And 5 take away 7 is negative 2. So this is a way that we can do the same work that we did before when we were looking at adding and subtracting polynomials, by grouping our like terms together before we combine them or simplify them. So I hope you find that helpful as we move forward in our algebraic unit or algebra unit. So one last question before we end this lesson. Let's go ahead and we're going to start by finding our x squared. So I'm not starting with my first term. So I'm looking for my largest variable first. So I have positive x squared minus 3x squared. Those are my like terms. The next one is my x's. That's the next largest. 5x and then plus 2x. And lastly, my constants, negative 2 and negative 3. So let's go ahead and put these in order from largest to smallest. I have my plus x squared, or I can just write it as x squared, minus 3x squared. Then I have this is a plus, so if there's no operation in front, it's denoted as a positive value. So I have plus 5x and then plus 2x. And lastly, our constants, negative 2 and negative 3. So last step, x squared, so this is a 1 in front. So 1 take away 3 is negative 2x squared. 5 plus 2 is 7x. and negative 2 take away 3 is negative 5.